In this class, we're going to go over practice question on speed, velocity, acceleration, and distance. Okay, let's start with the first question. A boy cycles continuously through a distance of 1.0 kilometer in 5 minutes. Calculate his average speed. Okay, solution. Please just pay attention. Okay, let's start by writing out the information and parameters that were given in the question. We are given that the boy cycles continuously through a distance of 1.0 kilometer. That means that distance equals to 1.0 kilometer. You understand? In 5 minutes. So the time is what? 5 minutes. Okay? We are asked to calculate his average speed. Speed equals to, we don't know it. Now, how do we determine the speed? From our previous class, speed equals to distance in meter now, okay, all over time in seconds, because the unit of speed is what? Meter per second. You understand? So distance all over time, that is the formula for calculating speed, but the distance is in what? Kilometer. So we have to what? Convert to what? Meter. You understand? Now, from your basic unit measurement, don't forget that 1000 meter equals to 1 kilometer. You understand? 1000 meter equals to 1 kilometer. So the distance in meter equals to what? 1000 meter. You understand? 1 kilometer equals to 1000 meter. Now, how do we convert the time from minutes to seconds? Don't forget that 60 seconds equals to 1 minute. Now, let x equals to what? 5 minutes. In this case, we are going to take the cross product. You understand? So x multiplied by 1 minute is equals to 60 seconds multiplied by 5 minutes. You understand? Divide both sides by 1 minute. This over 1 minute and this over 1 minute. So I'm going to, this will cancel this. You understand? This minute will cancel this minute. So I'm left with what? 60 times 5. So x is equals to 5 times 60 is what? That is 300 seconds. You understand? This will cancel this as well. Please, do you understand what I did? If you didn't understand, listen to the explanation again. We are given the time in minutes. I have to change the time from minute to seconds. You understand? And I know that 60 seconds equals to 1 minute. So I said let x equals to 5 minutes. So I take the cross product. X multiplied by 1 minute is equals to 60 seconds multiplied by 5 minutes. I divide both sides by 1 minute. So this 1 minute cancel this 1 minute. Hence, this minute cancel this minute. So I'm left with what? 5. 60 times 5 is what? 300 seconds. So the time equals to 300 seconds. Now, the speed can be now calculated as distance, which is 100 meter. Oh, 1000 meter, sorry. 1000 meter all over 300 seconds. You understand? So speed equals to 3.33 meter per second. You understand? So that is the solution to that question. Question 2. An Air Force jet flying with a speed of 335 meter per second went past an anti-aircraft gun. How far is the aircraft 5 seconds later when the gun was fired? Okay, let's start by writing out the parameters that were given in the question. We are given that the jet, an Air Force jet flying with a speed of 335 meter per second. So the first parameter there is the speed. Speed equals to 335 meter per second. You understand? Okay. Now, let's proceed. Went past an anti-aircraft gun. How far is the aircraft 5 seconds later after the gun was fired? Okay. The time that we're given is what? 5 seconds. Okay. Now, how far? Look at that question. How far simply means the distance. You understand? That is the distance. How far simply means the distance. How far is the aircraft 5 seconds later when the gun was fired? Okay. So we are asked to calculate the distance. We don't know the distance. Now, we are still going to use the formula of speed. Speed equals to distance all over. Oh, we still have the formula up there. Sorry. Speed is equals to distance all over time. So here I'm going to have speed is equals to the distance is unknown. So d all over t. Now the speed that we're given is what? 335. So I'm going to have 335 equals to the distance that I'm looking for all over the time. Here the time is what? The time is 5 seconds. So I'm going to have this over 5. Here I'm going to cross multiply. You understand? So for this I'm going to have d, which is the distance, equals to 335 multiplied by 5. Okay. So distance is equals to, if you punch your calculator, we're going to have 1,675 meter. 1,675 meter. You understand? That is the solution to that question. Okay, let's proceed to question number 3. A car travels with a constant velocity of 45 km per hour for 20 seconds. What distance does it cover in this time? Okay, let's start by writing out the parameters that are given in the question. We are given that a car travels with a constant velocity of 45 km per hour. So we are given that the velocity equals to 45 km per hour for 20 seconds. So the time that we're given is what? 20 seconds. Are you paying attention? Okay. So we are asked to calculate the distance that is covered. So we are still looking for distance here. Now we are given the velocity in kilometer per hour. Don't forget that velocity is measured in what? Meter per seconds. Okay. So here, since I know that 1 kilometer, 1,000 meter equals to 1 kilometer. Okay, let's go. 1,000 meter equals to 1 kilometer. So let x equals to 45 kilometer. You see, what I'm doing here is that I first want to change this kilometer to meter. You understand? So I'm still going to change the hour to seconds. You understand? Please, do you understand what I'm saying? The meaning of 45 kilometer per hour means 45 kilometer in 1 hour. You understand? So I want to change this kilometer to meter. Do you understand? So here I'm going to take the cross product. For this, x will be equals to 1,000 multiplied by 45. So x is equals to 45,000 meter. You understand? That is the 45 kilometer in meter is what? 45,000. Do you understand how I got this? I just take the cross product, x times this and 45 times this. So I have this. Do you understand? Like we did in the previous example, in the previous practice question. Okay. So now, having gotten 45 kilometer equals to 45,000 meter. Now, don't forget that 60 seconds equals to 1 minute, okay? And 60 minutes equals to what? 1 hour. Therefore, to get how many seconds will be equals to 1 hour? That means 60 times 60 will be equals to 1 hour. That will be what? 3,600 seconds, okay? So I'm going to have 3,600 seconds equals to 1 hour. Now, so since we know that 3,600 seconds equals to 1 hour, the velocity in meter per seconds will now be 45 kilometer will be what? 45,000 meter. You understand? All over hour, 1 hour. 1 hour is what? 3,600 seconds. So I'm going to divide this by what? 3,600 seconds. 45,000 meter divided by 3,600 seconds. That will give us 12.5. You understand? This is 12.5 meter per second. So that is the velocity. Now, velocity equals to displacement, which is the all over time. You see, though we are given that we should calculate the distance. Though we are asked to calculate the distance, you understand? The distance that we are talking about in velocity is what? Is displacement, you understand? Because velocity is a vector quantity, you understand? Hence, I'm going to have displacement all over time, you understand? So velocity is what? 12.5 equals to displacement is what we are looking for. So let us represent it as what? D all over time. The time that we are given is what? 20. Okay, so if you take the cross product, D equals to 12.5 multiplied by 20. So 12.5 multiplied by 20 will give us 250. So the distance is 250 meter. Do you understand? Okay, so let's have another question. Question 4. A body starts from rest and accelerates uniformly at 5 meters per second squared until it attains a velocity of 25 meters per second. Calculate the time taken to attain this velocity. Okay? In this class, we're going to go over past exam questions on general motion and uniformly accelerated motion. Okay, let's start with the first question. A body accelerates uniformly from rest at the rate of 3 meters per second squared for 8 seconds. Calculate the distance covered by the body during the acceleration. Okay, let's start by writing out the information that are given in the question. We are given that a body accelerates uniformly from rest. Now, you've heard that the body accelerates uniformly from rest. That means that the initial velocity of the body is what? 0. You understand? Because the body is not moving initially. Okay, so u equals to 0. Okay, the acceleration is what? 3 meters per second squared. So acceleration equals to 3 meters per second squared. Okay, now the time that we are given in the question, t equals to 8 seconds. Okay, we are asked to calculate the distance covered by the body during the acceleration. S is unknown. Okay, now looking at this question, how do we determine the value of s? To get the value of s, to determine the value of s, which of the equation of motion are we going to use? We are going to make use of the second equation of motion. You understand? The second equation of motion, because that one contains all the parameters that we have, including the parameters that we are also asked to find, which is the distance. You understand? The second equation of motion is s equals to ut plus 1 over 2 at squared. You understand? Now, because the initial velocity is 0, you understand? So I'm going to have s equals to 1 over 2 at squared. Do you understand? Because look at this. Listen, I'm going to explain, okay? Listen. U is 0. So I'm going to have s equals to 0 multiplied by t. 0 multiplied by t plus 1 over 2 at squared will also give me this. You understand? So when you hear that a body accelerates from rest, because this kind of question, you will find it in objective. So that is what JAMB tests you. JAMB overhead. You have to be very smart. You understand? So when you come across a question that says initial velocity is 0, you understand? So know that this is what? 0. This will be 0, because by the time you take the product of 0 and t, you're going to have 0. You understand? So the distance, the equation becomes s equals to half at squared. Do you understand? So here I'm going to have s equals to 1 over 2 multiplied by a is 3, multiplied by t squared. T is 8, so I'm going to have 8 squared. Okay, now s is equals to 8 squared is 64, 3 multiplied by 64 all over 2. S will be equals to, now 64 multiplied by 3 divided by 2, that is 192 divided by 2. You understand? So here I'm going to have 192 all over 2, hence s will be equals to 192 divided by 2, that will be 96 meters. You understand? So here I'm going to have 96 meters. So the answer to that question is 96 meters. Okay, so let's have another question. Question 2. A particle starts from rest and moves with a constant acceleration of 0.5 meters per second squared. Calculate the time taken by the particle to cover a distance of 25 meters. Okay, here we are given that a particle starts from rest. You can see that u is also the same. U is also 0, so u here will be what? 0. Do you understand? Because the particle starts from rest. Velocity, when an object is moving, it has significant velocity. But look at this, the particle is starting from rest, so that means that it is not moving before. You understand? So u will be equals to 0. Now we are given that the acceleration is what? 0.5. Okay, the acceleration is 0.5 meters per second squared, and we are asked to calculate the time taken by the particle to cover a distance of 25 meters. Time taken is unknown, and the distance is what? 25 meters. Now look at these parameters that were given. Which of the equation of motion suited the parameter? Should we use the first, which is v equals to u plus at, or should we use the second, s equals to ut plus half at squared, or should we use the third, which is v squared equals to u squared plus 2as? Which of these equations are we going to use? We are going to use the second. You understand? And the reason is because, number one, the second contains both the parameters that were given. It contains all the parameters that were given, and including the parameters that we are asked to calculate. You understand? So now s is equals to ut plus 1 over 2 at squared. Now I told you that anytime you come across a question that says initial velocity is 0 when the body starts from rest, that means that this ut will be what? 0. You understand? Because when you take the product of 0 and t, you're going to have nothing. You understand? So s will be equals to 1 over 2 at squared in that case. Okay, so s is 25, hence we are going to have 25 equals to 1 over 2 multiplied by 0.5 multiplied by t squared. You understand? Okay, take the cross product. We're going to have 50 equals to 0.5 t squared divided by 0.5. Are you paying attention? So here I'm going to have t squared equals to 100. Then you can take the square root of both sides. So t equals to 10 seconds. You understand? Please, do you understand how I got this solution to that question? See, anytime you come across a question that says initial velocity is 0 and you are using this equation, the equation becomes like this: s is equals to half at squared. Because when you take the product of 0 and t, that will be what? 0. So I substitute all these parameters. S is 25, a is 0.5, t is what we are looking for, and then I make t the subject of the formula, then I got 10 seconds. That is the value of t. Okay, the correct option to that question is, okay, we are not given the options. Okay, now let's proceed to the third question. How far will a body move in 4 seconds if uniformly accelerated from rest at the rate of 2 meters per second squared? Okay, please pay attention. Let's start by writing out the information. Now look at the first statement. How far? How far means what is the distance? You understand? So the first parameters is what you are looking for, that is distance. Are you paying attention? Okay, how far will a body move in 4 seconds? T equals to 4. Okay, in 4 seconds if uniformly accelerated from rest at the rate of 2 meters per second squared. So acceleration is what? 2 meters per second squared. Now uniformly accelerated from rest, so that means that u will be what? 0. You understand? U is 0 because the body is at rest. So here u equals to 0. When the body accelerates from rest, that means that the uniform acceleration of that body is what? 0. Okay, now how do we calculate the distance? The distance here is what? S equals to 1 over 2 at squared. So I'm very sure you understand the reason why I didn't have ut. The reason is because u is 0. You understand? So s equals to 1 over 2 at squared. Just put it directly like this. S will be equals to, now 1 over 2 multiplied by 2 multiplied by 4 squared. Do you understand? Okay, 1 over 2 multiplied by 2 multiplied by 4 squared, that is what? 16 meters. So the answer is 16 meters. Okay, these are the kind of question that if you come across, you shouldn't spend a lot of time. You understand? That is why I'm giving you shortcuts. Okay, so the answer to that question is 16 meters. Okay, so that will be all for this class. In this class, we're going to go over past exam questions on uniformly accelerated motion. Okay, let's start with the first question. A car takes off from rest and covers a distance of 80 meters on a straight road in 10 seconds. Calculate the magnitude of its acceleration. Okay, let's start by writing out the information that we are given in the question. We are given that a car takes off from rest. So we have question 1, solution. A car takes off from rest and covers a distance of 80 meters. So we've learned in our previous class that if a car takes off from rest, that means that the initial velocity of the car is 0. So in this case, u equals to 0. You understand? Okay, and cover the distance of 80 meters. So s equals to 80 meters. You understand? On a straight road in 10 seconds. So t equals to 10 seconds. Okay, so we are asked to calculate the magnitude of its acceleration. So here we are looking for acceleration. Now, with respect to this given parameter, which of the equation of uniformly accelerated motion are we going to use? don't forget, we have three equations of uniformly accelerated motion. Which of those equations are we going to use to solve this question? We are going to use the second equation of uniformly accelerated motion, which is S equals to ut plus 1 over 2 at squared. You understand? Now, because the value of u is 0, that means that S equals to 1 over 2 at squared. You understand? I told you in our previous class that when a car or a body starts from rest, the initial velocity of that body is what? 0. You understand? And because the initial velocity is 0, hence the value of ut will be 0, because when you take the product of time and 0, that will be what? 0. You understand? Hence the equation becomes S is equals to 1 over 2 at squared. Okay, so with this we can easily determine the magnitude of the acceleration. Okay, all we have to do is that we have to substitute all these parameters into this formula. We know that S is 80, so this is 80 meter equals to, okay, there is no need. By the time we are done, we're going to put the necessary units. You understand? Okay, S is equals to 80. 1 over 2 multiplied by A multiplied by T squared. T is 10, so I'm going to have 10 squared, okay? So 2 multiplied by 80, that is 160. So I'm going to have 160 is equals to A multiplied by 100, because 10 squared is what? 100, okay? Divide both sides by 100. This over 100. A equals to 1.6 meter per second squared. You understand? So the value of A, the magnitude of the acceleration is 1.6 meter per second squared. You understand? Okay, so let's proceed to the second question. Question 2. A bus traveling at 15 meters per second accelerates uniformly at 4 meters per second squared. What is the distance covered in 10 seconds? Okay, so let's start by writing out the information that we are given in the question. Okay, we are told that a bus traveling at 15 meters per second. Here, the initial velocity of that bus is what? 15. You understand? Because the ball is moving. You understand? We are not told that the ball starts from rest. The ball is already traveling at a particular velocity, which is what? 15 meters per second. So here, u will be equals to 15 meters per second. U equals to 15 meters per second. Okay? A bus traveling at 15 meters per second accelerates uniformly at 4 meters per second squared. So the acceleration equals to 4 meters per second squared. Okay? Now, what is the distance covered in 10 seconds? So the distance is what we are looking for, and the time equals to what? 10 seconds. Okay? So with respect to the given parameter, how do we calculate the distance? Which of the equation of motion are we going to use? We're going to use the second. And in using the second, we can easily determine the distance covered in 10 seconds. You understand? The second equation of motion is this. This is the second equation of motion. So here I'm going to have S equals to ut plus 1 over 2 at squared. You understand? S will be equals to u is 15, so I'm going to have 15 multiplied by t. T is 10 plus 1 over 2 multiplied by a, which is 4, multiplied by t squared, which is 10 squared. You understand? Okay, let's proceed. S is equals to 15 multiplied by 10, that is 150. So I'm going to have 150 plus these two here, these two, I'm going to have 2 plus 2 multiplied by 100. Okay, so S equals to 150 plus 200. So S equals to 350 meter. 350 meter. You understand? So the distance that the bus covered in 10 seconds is 350 meter. Now, if you compare this question with this question, in this question we are told that the bus, what's it now? The car takes off from rest. You understand? So that means that the initial velocity of that car is what? 0. You understand? So hence the value of this, the value of ut in this case, the value of ut becomes 0. You understand? Because when you take the product of 0 and t, you are going to have 0. So the equation of motion becomes like this. Now in this one, we are told that the board is already in motion. Hence the initial velocity is 15. So this one have a significant value. You understand? So that's why I have 15 multiplied by 10. Do you understand now? Okay. So anytime you come across question that says the the body starts from rest and you're using the second equation of motion, just know that this is what? 0. So the equation becomes like this, okay? So in an attempt to skip and make you to reduce, help you manage your time, you understand? Because this kind of question mostly come out in the objective, you understand? Okay, so let's proceed to the next question. Question 3. A body starts from rest and accelerates uniformly at 5 meters per second squared. Calculate the time taken by the body to cover a distance of 1 kilometer. Okay, we are given in the question that the body starts from rest, so therefore the initial velocity of that body is 0. That is question 3. The initial velocity is 0 because the body starts from rest. Okay, it accelerates uniformly at 5 meters per second squared. So acceleration is 5 meters per second squared. Okay, so we are asked to calculate the time taken by the body to cover a distance of 1 kilometer. So time is what we are asked to determine, and the distance is what? 1 kilometer. Okay, so but there is one important thing that I want you to take note. You can see that in this question the distance is in kilometer, hence we have to change it to meter, you understand? So don't forget that 1000 meter equals to what? 1 kilometer. So the distance is 1000 meter, you understand? Okay, so having changed the units to the necessary units, you understand, all you have to do now is to know with respect to the parameters that were given in the question, which of the equation of motion suited the parameter. The second equation of motion does that, you understand? So here we can do we're going to have S is equals to ut plus 1 over 2 at squared, you understand? But because the initial velocity is 0, you understand, so S is equals to 1 over 2 at squared. Okay, so with this formula we can easily determine the value of the time. Okay, so S is what? 1000 meters. So I'm going to have 1000 meter equals to, there's no need for this, equals to 80 squared 5 multiplied by t squared all over 2. Okay, so here I'm going to have 2000 is equals to 5t squared divided by 5. I'm very sure you understand how I got you understood how I got 2000. I take the product of 1000 and 2, you understand? Okay, so I got 2000, then divide both sides by what? 5. I'm going to have 400 equals to t squared. So t equals to square root of 400. So here t equals to 20. So the time it will take the body to cover a distance of 1 kilometer is 20 seconds. You understand? Okay, so let's have the last work example, last question for this class. A particle starts from rest and moves with a constant acceleration of 0.5 meter per second squared. Okay, 0.5 meter per second squared. The distance covered by the particle in 10 seconds is dash. A 2.5 meter, B 5.0 meter, C 25.0 meter, D 50.0 meter. Okay, that is question 4. Yeah, question 4. Okay, we are given that the particle starts from rest. So here u will be equals to 0, you understand? The particle starts from rest, u will be equals to 0, and acceleration is what? 0.5 meter per second squared. Okay, the distance covered by the particle in 10 seconds, S is what we are looking for, and the time is what? 10 seconds. So you can easily use the second equation of motion, you understand, to determine the value of S. So S is equals to at squared all over 2, you understand? S equals to 0.5 multiplied by t squared, which is 10 squared all over 2. So S equals to 0.5 multiplied by 100 divided by 2. S equals to 10. S equals to 10. Oh no. That is 50 over 2, you understand? Sorry. S equals to 50 over 2. So S equals to 25 meter, you understand? The correct option in that question is option C, You understand? That is JAM 1990. That is the question that we just solved. Okay, so you can see that it is easy to solve when you understand the basic concept. You understand? So that is a typical example that you might come across in your exams. Okay, so and this one provide question of exposure. You understand? Being exposed to the likely question that you might encounter in an exam, that is the best way to prepare. Okay, and that is why I take time to solve this kind of question. In this class, we're going to go over past exam questions on general motion and uniformly accelerated motion. Okay, let's start with the first question. A train has an initial velocity of 44 meters per second and an acceleration of -4 meters per second squared. Its velocity after 10 seconds is A 2 meters per second, B 4 meters per second, C 8 meters per second, D 12 meters per second, E 16 meters per second. Okay? Now, let's start by writing out the information that were given in the question. We are given that the initial velocity of the train, solution. A train has an initial velocity of 44 meters per second. So the initial velocity of the train is equals to 44 meters per second. Okay? And an acceleration of -4 meters per second squared. The acceleration is -4 meters per second squared. Now, let me quickly ask you a question. Based on what we've learned in our previous class, what kind of acceleration is this? This acceleration is known as retardation. You understand? This acceleration that you see here is known as retardation. Retardation is the kind of acceleration that brings the motion of an object to rest. You understand? So A is negative, which means that we are talking about retardation here. Okay? So let's proceed. Now, you are asked to calculate the velocity after 5 seconds. So here, the velocity is what we are looking for. We don't know the value, and the value of time is what? 10. Okay? After 10 seconds. Okay? Now, don't forget, in our previous class, I gave you 3 equations of uniformly accelerated motion. Now, which of the equations are we going to use with respect to the parameter that we are given in this question? We are given the u, which is the initial velocity. We are given the a, which is the retardation, -4 meters per second squared, and t is equals to 10 seconds. Now we are looking for v. Here, we are going to make use of the first equation of motion. First equation of uniformly accelerated motion, which is v equals to u plus at. You understand? Okay? Now, how do I know that we are going to make use of this equation? The reason is because with respect to the parameter that was given and the parameter that I'm asked to calculate, this is the formula that is suitable. You understand? Okay? So let us substitute the parameter that we're given into this formula to get the value of v, which is the velocity that we're looking for. Okay? Here, v equals to u. U is what? U is 44 meters per second. So I'm going to have 44 meters per second. Okay, there is no need of putting units. 44 plus a. A is what? -4 meters per second. So I'm going to have -4 multiplied by t, which is 10. Okay, v equals to 44 plus -4 times 10, that is what? -40. You understand? So v equals to 44 minus 40. So here v equals to 4 meters per second. Okay, this is the velocity of the train after 10 seconds. You understand? Okay, so let's have another question. If a car starts from rest and moves with a uniform acceleration of 10 meters per second squared for 10 seconds, the distance it covers in the last 1 second of the motion is dash. Okay, we are given the following option: A 95 meter, B 100 meter, C 500 meter, D 905 meter, E 1000 meter. Okay, now, okay, which the options that is correct, please pay attention. Oh, I've switched it. Okay, the correct option for the first question is that is option B, that is 4 meters per second, okay? So let's proceed to the second question. We are told that the car starts from rest and moves with a uniform acceleration of 10 meters per second squared. Now, question 2 now, okay? This is for question 1, okay? Question 2, solution. A car starts from rest, okay? A car starts from rest and moves with a uniform acceleration of 10 meters per second squared. Now, pay attention to the first statement. A car starts from rest. That means that it is not moving at all before. That means that the velocity at that point is what? 0. You understand? All this we have learned in our previous class. So if you missed the previous class, kindly check the playlist on this channel, Uniformly Accelerated Motion. Watch those videos. You understand? By so doing, then come back, you'll be able to solve all these questions that we are solving. You understand? I take time to explain all these concepts. You understand? So when the car starts from rest, that means that the initial velocity is what? 0. So u equals to 0. You understand? And the acceleration that we are given in the question is what? 10 meters per second squared. So a equals to 10 meters per second squared. Now, for 10 seconds, so t equals to 10 seconds. Okay? Now, what next are we given in the question? We are asked to find the distance covered in the last 1 second of its motion. The distance covered in the last 1 second. So, S in the last, let me just put it, last 1 second, okay? Now, the distance covered in the last 1 second is the difference between the distance in the 10th seconds and the 9th seconds. You understand? Please pay attention. The distance, you know that the time that you are given is 10 seconds. That is the time and the total time taken for the car to travel. You understand? Now, we are asked to calculate the distance covered in the last 1 second of its motion. That means that this distance that we are talking about is the difference between the difference of the distance between its 10 seconds and its 9 seconds. You understand? So, in an attempt to do this, which of the equation of motion are we going to use? We are going to make use of the second equation of motion, which is what? S equals to ut plus 1 over 2 at squared. S equals to ut plus 1 over 2 at squared. Now, this is the equation that we're going to use. Now, because we are told to calculate we are told to calculate the distance that the car covered in the last 1 second. The equation will come like this. S equals to ut plus 1 over 2a multiplied by t squared, t9 squared minus t10 squared. That is, please pay attention. I'm going to explain the reason why I put the equation like this. The reason is because the distance that we're looking for now is not the distance that is covered during the entire motion. You understand? It is the distance that is covered in the last 1 second of its motion. So that is why I have, oh sorry, this should be t10 minus t9. t10 minus t9. You understand? Okay? So that is the reason why I have t10 squared minus t9 squared. You understand? Okay? By 10 minus 9 is what? 1. You understand? That means that is the distance that is covered in the last 1 second will be the distance, the difference in the distance between the 10th seconds and the 9th seconds. You understand? So let's proceed. I'm going to have S equals to ut. So because u is 0, so t automatically will be 0, because when we take the product of t and 0, that will be what? 0. You understand? Even though we have a significant value of t, which is 10. 10 multiplied by 0 is what? 0. So here I'm going to have 1 over 2 multiplied by a. A is 10. All into brackets t10. That will be 10 squared minus, when t equals to 10, t will be 10 squared. When t equals to 9, that will be 9 squared. Okay? So here I'm going to have s equals to 1 over 2 multiplied by 10 multiplied by 10 squared minus 9 squared. That will be what? Okay, let's do it step by step. 10 squared is 100. This is what? 81. Okay? So here I'm going to have s equals to 1 over 2 multiplied by 10. Now, 100 minus 81, that will be 19. You understand? So here I'm going to have 19 So S equals to 1 over 2 multiplied by, now just take the division of 2 and 10. I'm going to have 5, you understand? So please pay attention, okay? Here I'm going to have 5. So I'm going to have 5 multiplied by 19, okay? You understand? So S is equals to 95 meter, you understand? So the correct option for that question is option A, you understand? That is 95 meter, okay? So let's proceed to another question. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third second? Okay, that's question 3. Please pay attention. A body starts from rest and moves with uniformly acceleration of 6 meters per second squared. Since the body starts from rest, that means that u is equals to 0. So u is also equals to 0, and a equals to what? 6 meters per second squared. Now, let's proceed. Also, we are given that, please, what distance does it cover in the third second? The distance is covered in the third second. So, S in the third seconds. Okay, now if you look at this question, you will realize that this question is similar to the second question that we saw. You understand? Now we are still going to use the same step. Okay, we are still going to use the same step. Now, but this question we are not given the time. You understand? Listen to pay attention to the question again. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does this cover in the third seconds? So we are not given a time, but notwithstanding, we can still determine the distance that it covers in the third seconds. All you have to do is that you are just going to plug in, we are going to use this same formula, you understand? So I'm going to have S equals to UT plus 1 over 2 AT squared. So I'm going to have T3 squared minus T2 squared. Do you understand? Because I'm looking for the distance that is covered in the third seconds. That means that the distance that is covered in the third second will be the difference of the distance between the third and the second. You understand? That is the difference between the distance the car or the body covers when t equals to 3 and when t equals to 2. That difference in distance, that is the distance that is covered in the third seconds. Do you understand? Okay, so let's proceed. Here I'm going to have S equals to UT. Since U is 0, that means that T will be what? 0. You understand? So here I'm going to have 1 over 2 multiplied by A. A is 6. So I'm going to have 6 into bracket 3 squared minus 2 squared. Okay, so S equals to 1 over 2 multiplied by 6. That is 3. 3 multiplied by 3 squared is 9 minus 4. Okay, S equals to 3 multiplied by 5, okay, S equals to 15, okay. The correct option is option A. You understand? The correct option is option A, and this is a typical example of question that might come across in JAM. You understand? So the correct option is option A. Okay. So, okay, before we round up this class, kindly take this practice question. A body accelerates uniformly from rest at the rate of 3 meters per second squared for 8 seconds. Calculate the distance covered by the body during the acceleration. Okay, that is WAEC 1992. Okay, so take that as a practice question. In our next class, I'm going to provide the solution. Okay.